as you can see, I have a little note for you guys. You asked for a video, ... Please watch it. Okay, so I'm going to split it into two like the last time, and hopefully you will watch both videos and not just one. Alright, so the first thing says, convert the following degrees. There will be no calculator for this. So basically, how are your math skills with fractions? So you do 160 times pi over 180. Leave this as a variable. And since you can't use your calculator anyway, you shouldn't really worry about, pressing the pi button. So your answer would be 160 pi over 180, which if you cross out the zeros is 16 pi over 18. These both are divisible by 2, and that's why the final answer is 8 pi over 9. The next one, you're going to do the same thing. Do not change this by adding 360. Just leave it as negative 440. And multiply it to pi over 180. Put it together. And you get negative 440 pi over 18. The zeros cancel out. You're left with negative 44 over 18. Again, both of these are divisible by 2, making this answer negative 22 pi over 9. Okay, really easy stuff. Just really concentrate. Okay, the next thing is knowing your unit circle. Okay, I went to Google and I got this unit circle from there. And basically, here are your degrees all around the circle. And then on the outsides are your sine, cosine, and sine coordinates. And then your radians are there. Now, before we go into these questions, here's an easy way to remember your unit circle. So we always start with 0. Then it's going to be pi over 6, pi over 4, pi over 3, pi over 2. You should just memorize those, okay? Or you can just remember it's 2, 3, 4, skip the 5, 6. Now here on this side, a good way to remember is 2, 3, 3, 4, 5, 6. Okay? 2, 3, 3, 4, 5, 6. Okay? And that would be for 120, 135, and 150. Now on the other side, it's 3, 4, 4, 5, 6, 7. So that's starting at 240. 3, 4, 4, 5, 6, 7. That's in the third quadrant. And then the last quadrant, there's no pattern really. Just remember that the last number is 11 pi over 6. And this is 5 pi over 3. So I don't know any funny, crazy ways to remember that. The other way you can remember your unit circles to count to 12. So 1, 6, skip 45, 2, 6, 3, 6, 4, 6, skip 135, 5, 6, 6, 6, 7, 6, skip 225, 8, 6, 9, 6, 10, 6, skip 315, 11, 6, and altogether that would be 12, 6. Now when you get to the 45, you count, and you have 4s in your denominator. So it's 1 over 4, 2 over 4, 3 over 4, 4 over 4, 5 over 4, 6 over 4, 7 over 4, 8 over 4. Alright, so 2 different ways to remember your unit circle. So remember that, please, because you need to know that for your test. Alright, so I'm going to minimize this now so that we can use it for our questions. Okay, so there is your unit circle. Unit circle, unit circle. 4 quadrants, 4 quadrants. Sine and cosine. are y and x. 4 quadrants. 4 quadrants. Alright, that's just my little song. Alright, first one, sine of pi over 6. Pi over 6 is 30 degrees, so the sine of 30 degrees is 1/2. The next one, secant of 3 pi over 4. Well, 3 pi over 4, that is the second quadrant, and that is going to be one of the 45, so that's 135. So this is the secant of 135. Well, we know that secant is associated with cosine. So the cosine of 135 is square root of 2 over 2. You should know that, with a negative. So to get the secant, you're just going to flip it and do the reciprocal. So the reciprocal would be 2 over negative square root of 2. As you know, you are not allowed to have a radical in the denominator. So we multiply by that radical, and we're left with negative 2 square root of 2 all over positive 2. Now the 2's can cancel out, and your final answer would be negative square root of 2. Alright, the next one is negative 5 pi over 3. Now you could just look for 5 pi over 3, which is 300, and then just negate it, or you can go around the circle backwards. And that would take a long time, but, because we never really went around the circle backwards. But if we were to go around the circle backwards, then this would be, right here, would be pi over 6, negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2, negative 2/3 pi, etc. And by the time we got around this point right here, which is 60, would be negative 5 pi over 3. So if you decided to take your unit circle and, put it upside down, okay. So here's my unit circle upside down. Then the 5 pi over 3 that we're used to, well, where is 5 pi over 3? It's over here. That would be, well, that's not working the way I wanted it to. Because if you flip it, the 5 pi over 3 should be in this quadrant. Well, anyway. Oops. Let's forget that for a second. But you can also do the reference angle like we did in class. So remember, the reference angle would be, so this winds up being negative 300. And you just add by 360 and get 60 degrees as the angle that we're really looking at. But remember, these are radians. So you could always just add 360 is 2 pi to that and get the same answer. Okay, so this would be negative 5 pi over 3 plus 6 pi over 3, because 6 divided by 2 is 2. 6 divided by 3 is 2. And you're left with pi over 3. So it's the same thing. I did the same thing, got the same answer. So the cosine of 60 is 1/2. Or the cosine of pi over 3 is 1/2. Okay, I hope I didn't confuse you too much, but I got the 2 pi from here. Alright, tangent of pi over 2 is the same thing as tangent of 90. Remember, tangent is y over x. So 90 is the coordinate 0, 1. So 1 over 0 is undefined. Remember, you cannot have a 0 in the denominator. Alright, so we've got 7 and 8 to look at now. So I'm just going to move these up. So I hope you guys have the answer for 7 and 8. because I'm going to erase those. And if you're still writing in the answers for 9 and 10, I'm going to keep that there for you. Alright, next one is cosecant of pi. Pi is the same thing as 180. So remember, cosecant is associated with sine. So the sine of 180 is always the second number, so the sine of 180 is 0. Well, the cosecant would be 1 over sine. So the cosecant of pi would be 1 over 0. Remember what we said over here about 0 in the denominator. So this answer is undefined as well. Alright, the next one is 7 pi over 2. Yes, I know that 7 pi over 2 is not in the unit circle, but it can be. If we just decided to continue going around the unit circle again. Now, a unit circle can also be your wave, like your sine wave. So if we're going 0, pi over 2, pi, 3 pi over 2, and then 2 pi, then we can keep going. After you go to 2 pi, then you would go to 5 pi over 2, and then 3 pi, 7 pi over 2, and then that would be 4 pi. So if you notice right here, these two share the same value. 3 pi over 2 and 7 pi over 2. Okay? So that means whatever answer you have for 3 pi over 2 will be the same for 7 pi over 2. Now if I were to show this in the unit circle, if you see here we have 0, then pi over 2, then pi, then 3 pi over 2, then 2 pi. Now if I keep going around again, what comes after 2 pi, which is really 4 pi over 2, is 5 pi over 2. Then 6 pi over 2, which is really 3 pi. Then 7 pi over 2. So 7 pi over 2 and 270 share the same value. Okay, so 7 pi over 2 is just, a second rotation. So that means this is the same thing as the cotangent of 270. So we need to know what the tangent of 270 is. And that happens to be negative 1 over 0, which is undefined. Meaning that the cotangent of 270 should be 0 over negative 1, which is simply 0. Okay, so this is a lot of stuff that you did for, the first test in this unit with degrees. So it's the same idea except it's with radians. Alright, the last part of this is also looking at the unit circle, but just working backwards. Now we actually have the answers, which are these outside numbers, and we need to use these outside numbers to get the degree measurement. Alright, so let me make this a little bit bigger. I will block probably the last two questions and then I'll bring it back up. Alright, so the first thing it says tangent is equal to negative 1. Remember that tangent has three main values. Those main values are square root of 3 over 3, and that's for 30 degrees or pi over 6. The next one is 1. That's for 45 degrees or pi over 4. And then the last one is just square root of 3. That's for 60 degrees or pi over 3. So anytime you see something with tangent, remember one of these three numbers. Now, they want the tangent answer to be negative 1, which means that I have to look at the quadrants where tangent is not positive. Well, tangent is positive in this quadrant because everybody's positive. And tangent is positive in the third quadrant because both of these are negative. So that means that tangent must be negative in the second quadrant and in the fourth quadrant. So because I am associating the value of 1 with all of the angles that are associated to 45, if I make my bow tie, all the angles that are associated with 45 would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Those are all of my 45s. So now out of those, I want to pick the ones that are negative. So that means that 3 pi over 4 is negative 1, and 7 pi over 4 is negative 1. So that means the answer to this question is 3 pi over 4 and 7 pi over 4. Alright, the next one is cosecant. Cosecant of theta is equal to 2 square root of 3 over 3. Which means I need to know what the sine is equal to. So if I were to do the reciprocal of this, just in case you don't remember that this is the reciprocal of an important number, then I know I'm not allowed to have radicals in the denominator. So this is 3 radical 3 over 2 times 3. These 3's will cancel out, making this a sine of theta equal to square root of 3 over 3. When in doubt, do the reciprocal if you have no idea what to do. Alright, so I need to know where is sine equal to square root of 3 over 2. Well, if I look at my trusty unit circle, and sine is my second number, it's equal to square root of 3 over 2 at pi over 3 and at 2 pi over 3. In the other sections, they're negative, so it's only those two answers. So the answer to this question would be pi over 3 and 2 pi over 3. Alright, I hope you guys have those two because I'm going to erase them. Alright, I'm going to move this up so we could look at the next two examples. Alright, the next one says sine is equal to 1/2. So I have to look at my unit circle, and mind you, if you need to write this for yourself on your test, you should. It'll help you get at least the entire first page of your test, which is the multiple choice. Alright, so we look. Sine is the second number, so it is 1/2 here at pi over 6 and here at 5 pi over 6. In the other two sections, it's negative, so I can't use those. So pi over 6 and 5 pi over 6. Alright, the last one says secant is undefined. So remember, secant is associated with cosine. If secant is undefined, that means it's either 1 over 0 or negative 1 over 0. That means it has to do with the axes. So that means that we are looking for where cosine is going to be equal to 0 over 1, which is 0, or or just 0, just like that, and not 0 over 1. So I gotta figure out where is cosine equal to 0. Cosine is the first number, so that means it's 0 here at pi over 2 and here at 3 pi over 2. Okay, so those are those answers. So here is my advice for that section. I'm going to write it real slow. Can y'all read cursive? What does that say? Ha! It's in cursive. I should know how to read cursive. Okay, memorize your unit circle. That's what it says. You guys should have memorized your unit circle from the beginning, so this is just, you know, extra memorization. You've taken numerous warm-up quizzes on the unit circle, so by now you should be a whiz. You should be able to look at your unit circle and be like, oh yeah. Alright, so that's that. Alright, no more unit circle stuff. Now we're going to move on to sector, length of the sector and area of the region, or actually it's length of the arc and area of the sector. Alright, there are two formulas that you really do need to know. You need to know this formula, which represents the length of the arc, and it comes from the radius times the angle, which is the central angle, in radians. Which means that if they give it to you in degrees, you must change it to radians. Alright, in this case, it gives us a diameter of 20 meters. Most of you knew to cut that in half, making my radius equal to 10 centimeters, and that's going to go right here. Then it says find the length. So since you're finding the length, we're looking for S, intercepted by a central angle. So here's that angle. So that means that's theta, measuring 3 pi over 4. Okay, so we have all of the information that we need to plug in. So our S is what we're looking for. Our radius is 10, and the central angle is 3 pi over 4. Now you're going to leave pi alone, and you're going to leave it as a variable. Only change it using the pi button if it says round to the nearest tenth, or if your answer has already been given to you out of pi form. So now we'll just work it out. 10 times 3 is 30 over 4 pi. Now since they both can be reduced by 2, that's why the final answer is 15 pi over 2. Please, no decimals. And also make sure that you put your unit, which is what I forgot, and it's centimeters. Okay, because you do not want me to take off points because you left off your unit. Alright, that's pretty much something you'll see tomorrow. I mean, this was not a hard question. Okay, 14 says find the radian measure. So that means you're looking for theta of the central angle whose intercepted arc. So the intercepted arc is S. So S is 24 inches. And an 8-inch radius, that's R. So you have all the information that you need. So you write S equals R theta. The S was 24. The R was 8. And we're looking for theta. Simply divide by 8. And theta equals 3. Now, it's not 3 pi. It's not 3 degrees. It's 3 radians. All angles, all of them, must be in radians. Alright, so that one wasn't bad. You might see one like that. Alright, this one was the crazy one, and I would prefer not to do it because most likely you won't see it tomorrow on the test. So I'm going to skip it. I will just write out the work for you so that if you do see it on a final exam review or anything, you will have that as a resource. Because just because we don't give it to you on a test doesn't mean we won't give it to you on the final exam. So I know a lot of you were sleeping once I was doing this problem because it was so many steps. Back in the day when I was in pre-cal, it was a lot more steps than this because we weren't allowed to use a calculator. So in this particular example, you are allowed to use your pi button in your calculator because they gave this answer in radians. Okay, so I'm just going to continue this. You can just fast forward if you already wrote this down. Or you can go and get yourself something to eat. Okay, remember in class we talked about multiplying by the reciprocal. Okay, and in fourth period I reduced that, so I'm just going to reduce it for you guys here. And now in your calculator, just take the square root of this, and that's how we got that r was 5/6. Okay, so if your radius is 5/6, they do want the length of the arc, so they're looking for s. So then you just replace everything into this formula. So 5/6 times 10 pi over 9. This was the theta. This was the radius. You can use the pi button, and that's how we got 19.5. Alright, it's pretty long, kind of stressful, but use the pi button. And then for this one, use the pi button. Okay, you use it because they didn't give us anything in pi form. Alright, last one is something that you might see. My favorite part is if you got to eat this slice of pie, what kind of pie would it be? Now, I put cherry pie, and in another class I put pumpkin pie, and then someone even said mango pie, which sounds kind of gross. But actually, if it was up to me what kind of pie I would have the All-American apple pie. A la mode. Because apple pie a la mode is so good. You just get some really good vanilla ice cream, and then you heat up your apple pie a little bit and put some ice cream on it. It is to die for. Alright, so aside from breaking out of character for a sec, ooh, that looks like an egg. Whenever we talk about area of the sector, we're just taking a piece of the pie. Your area is this whole entire section here. So they told us that our area was 8.26 inches squared. And then they said that our diameter, which we know is 16, that means that the radius must be 8. So this is 8 square inches. That has to be our area. And they said, what's the degree in radian measure? So once you're asking for degree in radian measure, you're asking for theta. Okay, so we just plug that into our formula. Remember, this will not be given to you, so just remember half of r squared, theta. 8.26 equals 1/2 of 8 squared. 1/2 of 8 squared is 32. Divide both sides by 82, and you get this long, ugly decimal, 0.2 0.5825 radians. If you do want to round it, I know I told you not to round it in class, but you can round it to 0.3 radians. But, and I say this big but, when you are trying to find the degree measurement, I want you to put that as your degree measurement to find the degree measurement, which is simply multiplying by 180 over pi. And that's your pi button. Yeah, put this whole thing because it'll give you more of an exact answer. And then you can round it to 14.8 degrees. So that's your degree measurement. This is your radians measurement. So make sure you know this. Alright, so here is secret message number 1, because we are at the end of this first video. Secret message number 1 is right here. Okay, I am not going to put the secret message on Edline because I know that everyone's looking on Edline and they're not looking at the video. So as you can see, you have to wait to the end of video number 1 to get the secret message. So that's secret message number 1. Alright, so good luck and stay tuned for video number 2.